All right, today we are going to go over part 3 of the equivalent expressions lesson. And basically the focus here is that we are asking how can expressions such as 3x plus 7x or 3x plus 2 be written in equivalent form. And we kind of answered this yesterday on the 3x plus 7x in the form, in that form, because we can combine like terms. However, in the 3x plus 2, we did not really answer this question. But especially since if we apply order of operations, we'd want to work within the parentheses. We can't really do that because x and 2 are two different things. So we would want to use the distributive property. And in math, we actually use the distributive property a lot more than we do the order of operations. So it'd be a good idea to keep the order of operations in our mind, but really the distributive property is going to come into play a lot more. And we call it the distributive property because in a situation where we have 3 times the quantity of x plus 2, we would distribute the 3 to the x and to the 2 and get the expression of 3x plus 6. Okay, so we can also take it, and what they're getting at here, 3x plus 7x, is we could factor out the x and get that as x times 3 plus 7. I really don't like this right here because this should just be an x plus, or x times 10, which would then be 10x, which we can get by combining the like terms and get 10x. So we're really not going to talk much about this one. We're really going to specifically stay with distributing and getting that distribution. So we are going to take a look at the expression of A times the quantity of B plus C, which would be the two side lengths here is called factored form, and that when we have them out as A times B plus A times C, that is expanded form, and that both of these are equivalent expressions. So again, we run into the question of 5x plus 6x. However, again, this is not really a great question because if we combine like terms, that gives us 11x, whereas if we pull out or factor the x, if you see here, this is in expanded form, and if we factor out the x, we would get x is 5 plus 6, thus giving us x times 11, and it leads us back to 11x. Not really a great way to explain the distributive property. Now, so we're going to move on. Okay, so we are going to continue our bike rental operation tour discussion and say that they have made a list of operating costs where the bike rental is $30 per person or 30 in, whoops, that's in yellow. Let's redo that in something darker to where it'll show up. So bike rental would be 30 in. Food and campsite rental would be 120 per person, 120 in, and the rental of a bus and trailer for the bikes is a flat fee of $1,000. Not per person, just a flat fee of $1,000. So, what equation can represent the total costs here? Well, we have a couple of options. We could simply add them all together. We could add in the 30 in for the bike rental, the food and campsite rental, which would be 120 in, plus the $1,000. So that's one option. Another option would be that using combining like terms, we would have 30 in plus 120 in. That would give us 150 in plus 1,000. Now these are the two that we should be using. We would want not to do 1,150 in because this is not per person, okay? So we don't want to do that. But these two equations should give us the correct amount. And one way to test that would be to do a simple check of our answer. So let's say that n equals 5 for a second, and let's test our equations. So that if n equals 5, okay, then if we do 30 times n is going to be 30 times 5, which is going to be 150. 120, n would equal 120 times 5, which equals $600. And then we'd have our $1,000. Okay, so if we put it in this expression, that would be 150 plus 600 plus 1,000. Okay, ran out of room there. So I'm going to erase that and rewrite it to where it's all on the same line. I apologize for that. So 150 plus 600 plus 1,000. Okay, so 750 plus 1,000. This should be 1,750. All right, and that would be for 5 customers using this equation. And then if we go down here to the 150n plus 1,000, we go 150 times 5, that should be a 0, plus 1,000. We would get 150 times 5 is 750. Whoops, 750, not 7,500. Trying to get through this pretty quick. 750 plus 1,000, and that equals 1,750. And they are equal. So both of these expressions are equivalent, which means that they're equal. All right. All right, and finally I will show an example using the distributive property that 2 expressions are equivalent. I will show that 1 plus 3n is equal to 4 plus the 3 times the quantity of n minus 1 by distributing the 3 to the n minus 1. So first thing we're going to do is, all right, so the next thing I'm going to do, and the last thing I'm going to do, is show you that through the distributive property that 1 plus 3n is the same thing, or an equivalent expression for 4 plus 3 times the quantity of n minus 1. So first thing I'm going to do is recopy the expression that 1 plus 3 times n is equal to 4 plus 3 times n minus 1. All right, now using the distributive property, I am going to distribute the 3 to the n and to the 1, which means I'm going to multiply everything inside the parentheses by the term on the outside. Since the 3 is right next to the parentheses, there's nothing here to indicate that there should be anything else done. That tells me mathematically that I am multiplying everything on the inside by 3. So we're going to rewrite 1 plus 3 n equals 4 plus, this is what we're doing right now, 3 times n would give me 3n, and then 3 times 1 is 3, and I'm going to go ahead and leave that subtraction sign there right now. Okay? Now, the next step here would be to rewrite 1 plus 3n equals 4 plus 3n. Since addition is commutative, I can switch the order of this and say that 3n can go here plus 4 minus 3. Okay, I can change the order. This is commutative. I can move the 3n to the front, move the 4 around, leave the subtraction of 3 on the end. I didn't change the value of any numbers. Technically, this 4 is a positive 4. This 3n is a positive 3n, and so I didn't change anything. All right, now, next thing I'm going to do is I am going to subtract this right here, that 4 minus 3. We're going to show that. So 1 plus 3 n equals 3n plus 4 minus 3 is 1, so plus 1. Since this is addition again, I'm going to rewrite things back the way they were by flipping this guy around. And so 1 plus 3n equals 1 plus 3n. And so this side of my this side of my equation over here stayed the same the entire time. And everything over here changed based on the distributing of the 3 to everything in the parentheses. All right. If you need to rewatch anything, please do. I will see you in class.